techniques. Today we are going to learn about a new data structure, and that is linked list. So this is a very interesting topic. The first thing you need to know about is that this is a linear data structure and it stores a list of items just like array. So what is the difference between array and linked list? It is that inside linked lists are called nodes, which are stored randomly inside the memory, whereas in arrays, the elements are contiguous and they have to be stored sequentially. So this linked list might be new topic for many of you. So I hope you are going to learn something new today. So let's see how you can visualize list. So linked list consists of nodes, different nodes. A node basically consists of two data fields. The first one is data and the second one is a pointer which basically stores the address of the next node. So each node is pointing towards another node. The first node is pointed by a pointer. We usually name it head. And the last node consists of the data field, whatever you wanted, and the next field, inside the next field, it contains null. What it means that this node does not point to any other node. This is the end of the linked list. So let's see with an example how the addresses are stored. So you can see head over here is storing the address 2000. So whenever we read head, this is a pointer. We go to the address to see this node. It consists of a data 7 and the pointer with address 3000. So when we go here, we are pointed towards this memory location, that is 3000. So we move ahead and go to the memory location 3000. Over here we see our next node, which consists of 10, that is the data at the current addresses. So these 7, 10, 20 and 1, these are the current these are the data at the current address, and these, the next field in a node, it is a pointer which consists the address of the next node. So you can see over here, we see this node is storing address 4000. So we go to the location 4000. That is our next node, which consists data value 20. And the next address is 5000. So here you can see it only consists of data field, which is 1. And its pointer is null. It is pointing towards null. So there is no other node after this node. Right. So this is the end of the linked list. Next is what are the differences between linked list and an array? So the first thing you can see over here, arrays have fixed size which you cannot increase after you initialize it. Right. But in linked list, you can alter the size of linked list whenever you want. So this is also called dynamic memory allocation. So this linked list have dynamic size. The next point, in array, insertion and deletion are inefficient, whereas insertion and deletion are efficient. So we are going to talk about deletion later in this session. Let's move on to next point, which is about random access. So in arrays, you can randomly access the elements using the index, right? But you cannot do that in case of linked list. You have to traverse starting from head and to the next node and to the next node, right? In case of arrays, memory might be wasted if the array is not full. But uh, linked list allocate the memory dynamically. So according to our need, that is whenever we need to insert a new node, we can insert it, and if we don't need it anymore, we can just delete it. So there is no waste of memory. The next thing we have, if we want to sequentially access an element, this becomes faster inside an array. This is because elements are stored in contiguous memory location, that is one after another inside the array. But this is slow because we have seen the nodes are randomly placed inside the memory, right? So where were we? Yeah. So sequential access is slow inside the linked list. So how you can initialize a linked list using C++? We have a code over here. Don't get scared by seeing these class and constructors. This is very simple. You have to create a class, and class is created simply by writing class and then the name of the class, whatever you want it to be. In this case, we are constructing a node in this class, so we have named it node. The next thing is what do you have inside a node? Node contains a data field and the next field, that is the pointer pointing to the next node. It contains the address of the next node. So we have taken over here, data can be simply declared as in data, but if you want to take the pointer storing the address of the next node, so pointers are used by this pointers can be used by using this star symbol. So whatever is written after this asterisk is the name of the pointer, and before the asterisk we write the data type whose address this pointer is storing. So for nodes, each node is each node is containing the address of the next node. So this next pointer will contain the address of the next node. So the data type becomes node. Therefore, we have written node star next. Right. These two are data members. These two are called data members. For public, we have written public over here because we want to access these data members outside of this class. So by default, if you don't write public over here, these are private and you cannot access these outside of this class. If you want to use these outside of this class node, you cannot use them. If you want to use them, in this case, we do want to use them. So we write public over here. Whatever is written after public, we can use it outside of this class. So the next thing we do is we make a constructor. So how can we do that? We just write the name of this class, that is node, and the values that we want to give to these data members. In this case, we are just going to give the value to this data field, and the next we will initialize it as null. So we return here node int value val, and whenever this constructor is called, whatever value we pass inside these brackets, it will be given to the data field and the next field will remain null. So what this block of code does, it creates a node like this. The data field consists of val and the next field right now it is pointing towards nothing. It consists of null. So can you access data fields in a node? This you can do by node name, by writing the node name, whatever your node name is, and you can use this hyphen and this bracket. This is basically an arrow, and whatever data field you want to access, you can write afterwards. So here first line is used to create a node. You can see we have called this constructor node over here, and we are passing 12 inside the data. So what this does, This creates a node with the data field as 12 and the next field as null. We are doing it by this new operator. What this new operator does, this is used to dynamically allocate some memory. What it does, it creates a new node or whatever you want you have written after it. It can even create new integers, but in this case we are creating a node, and you have to use pointer to store this new node because we are using new operator. So you can see this, it's this node's name we have written over here is first, and it is a pointer pointing towards the node. So whenever we want to access this data, how we can write it? We write the node name, arrow, and the data field. That is first arrow data, this will return 12. And first arrow next will return whatever is there in the next field. So I hope this is clear. Let's see. Oh. So this is the implementation of linked list in Java. Those who code in Java can take a look at this. So next we're going to talk about insertion and deletion inside an array. Inside a linked list. Now you will understand why we said that insertion and deletion are efficient inside a linked list. So you can see this is the initial linked list that we are provided with 7, 12, 10 and 11. And this is pointed by head pointer. And we want to insert this temp node over here after 7 and before 12. So what we have to do? What we have to do is we have to update the address that this node is containing. So we will write the address of this node in the next field of this node. So what will happen? This node will contain the address of this temp node and it will point towards this node now. This link will be broken and this will look something like this. The next thing we have to do, we have to also connect this to the next node. If you want to connect two nodes, you just have to use their addresses. So to connect these two nodes, we write the address of the second node inside this temp node. So what this will do, this node will point towards the second node. So now you can see we have easily inserted a new node inside our linked list. This will traverse like this 7, 100, 12, 10 and 1. The rest of the linked list remains unchanged. We don't have to know anything about this thing. So this is how you perform insertion in a linked list. Next, let's see deletion. So here you can see initially we are provided with this linked list. And let's say we want to delete this 10 element, this node, right? So what we have to do, the rest of the linked list remains unchanged, this one. And we have to update the address inside this node. The pointer containing the address of the next node will be provided the address of this node. We will just skip this one. And the address of this node will be provided in this node. So now this node will be pointing to this, and you can just break this link as well and deallocate the memory for this node. So the linked list just becomes 7, 12 and 1 after this. So now you see how easy it is to delete and insert element, how efficient it is. You can just delete this block when you don't need it. So the next thing is the type of linked list we have. These we can divide based on the links the nodes have with each other. The first one is singly linked list. So singly linked list consists of one link field, right? It is only pointing towards the next node. Each node will only be pointing towards the next node. It does not contain any information about its previous node, right? So you can only traverse this linked list in one direction, that is left to right. Why? Because suppose you just go from head to this first node, then second node, and then third node, then fourth node, you cannot go backwards because this node does not contain address of this node or any information about this node, right? The next type of linked list is a circular linked list. The only difference this has is the last node, instead of pointing towards null, it is pointing to the first node. Okay, so basically, this circular linked list does not have any first or last node. This just becomes a cycle, right? You can see over here. The next type of linked list is doubly linked list. Now, in this type of linked list, each node contains two addresses, the address to its next node as well as the address to its previous one. So this is also called a two-way list because you can traverse it in both directions. Suppose we go from here to the second node to the third node. Now if you want to go back, you can go back to this one because this node will be containing address to its previous node as well as its next node. So these type of linked lists are maintained by using list head and tail pointers. So next, let's see the basic operations you can perform on linked list. We have seen how you can create a linked list. The next thing is how you can traverse, that is move from starting to end of a linked list. Third is inserting an element inside a list. Fourth is deleting a node. And the last is concatenating two lists. Concatenating means joining two lists together into one. So this is it from the theory side. Now we are ready to move on to questions. So for that we have Akansha with us. Over to you, Akansha.
Okay, thank you, Shreya. So, first of all, let's see the problem section. Shreya, can you stop the sharing of the screen?
Yeah,
Okay,
I've done.
let me just share my screen. Okay, so just let me know whenever, Shreya, please let me know whenever my voice cracks up or the screen is not visible, okay?
Yeah, okay.
Okay. So, linked list. Now, first of all, see, linked list is really from the interview's point of view, it's a really an important topic. And the implementation is also easy, but the main fact is that in linked list, once you understand how the insertion and the deletion operations are performed, if you understand it clearly, then I can bet on that you can that you can easily do the other questions related to linked list. So it's very important to understand how the insertion and the deletion operations works in linked list. So I'm doing the code here in C++. So for those who are doing in Java and Python, don't worry. See, yesterday we have shared the GitHub repository. So I will make sure to paste the code for Java and Python along with the C++ code. So you can check it from there. Okay, so let's start it. Now see, I'm going to perform the operations. So there are several operations that we can perform on a linked list, which she has already told you. First, the traversing, insertion, deletion, concatenation. So today we are going to see the traversing and the insertion operation. Right now. Okay, let the code is okay. So first of all, this this code here. Now, this is the concepts of OOPS. How many of you have know already something about OOPS? Object-oriented programming. How many of you have learned OOPS already or know about it, something little bit? See, these classes, basically, अगर मुझे पूरा explain करना पड़ेगा तो मुझे पूरा OOPS समझाना पड़ेगा उसके लिए. So I will share some videos related to OOPS concepts in C++ and Java for both. You can see it, but for now, you can just consider this as that this whole code is representing a single node, a single element in a linked list, right? This whole code is representing a single node. Just understand this for now. And this is my main function. So in the main function, what I've did is I've created a node with the name head. And inside that node, I have added a value of 1. Similarly, I have created a second node, and that second node contains a value of 2. And similarly, I have created a third node, which contains a value of 3. Right? Now, these are the values, and I'm here pointing. See, अगर code थोड़ा सा भी मतलब problem आ रही है समझने में, just understand, just see what I'm saying, because it may be possible that you are not understanding the code, but you need to understand the main concept behind it. Okay. So this line is adding the value. See, this is the node head, and it contains value 1. Second contains 2 value, third contains 3 value. Now, in the next case, I am pointing, this head is pointing towards the second element. And this second node is pointing to third element. I'm using here the next keyword. What does this represent is, you can see, in my linked list is like this now. 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to null. This is my current linked list. This whole code represents this. Okay? Now, let's see how I can print this. I want to traverse this whole linked list. Let's see how I can do it. Okay. So this is, so here I'm going to write how we can traverse the linked list. And this is a function, display. So what does this function contain? See, in this display function, I will pass a node. And this node can be any node. It can be head, second, or third. It depends on me from where I want to print my linked list. So for now, let's see. I'm passing in this function display, and I'm passing, let's say I'm passing the head. Okay, which means I'm passing this one value, this head node. I'm passing only a single node, which is this head node, right? Now, in this function, let me just write, I'm printing. थोड़ा समझ आना. I will explain the code just later on. Just let me write it first. Okay, so here you can see in this function, what I have did is, I am taking a node in this display function. This display function is taking a parameter, which is a single node. And what I'm doing, I'm running a loop here. And this loop is gonna run until, this loop is gonna run till our node is pointing to a null. Right? This loop is gonna run till our node is pointing to null. So let me just run this code first. my output should be this 1, 2, 3, and null. Let's see. Okay, let me explain it again. See here, I'm passing a node, and here in this function, I pass the head node. So head node means only one node is going, only one node I have passed in this function. Now I'm running a loop, and this loop is gonna run until or unless we reached a node which is pointing to null. And here I'm printing this node, n of data, and then I'm making sure that my node moves forward towards the next node by this statement, n is equals to n dot next. So in this way, I'm printing this whole list 1, 2, 3. So what if I don't want to start from the one? Let's say I want to start from the second. Now, if I passed my second node, so what should be the output? Now I'm not passing the head node, I'm passing the second node. So what should be the output for that? Okay, see, now I'm passing the second node. So the output should be what? 2 is pointing to 3 and 3 is pointing to null. This should be the output. So traversal is simple. You just need to apply a loop, and in that loop you are printing the value of this node, and then making sure that your node is moving to next node in that manner. Okay, so this is the traversal code, and then let's do the insertion part. So first of all, there are 3 different ways that we can insert any element or any node in the linked list. So the first way is to insert a node at the front of the linked list. Second way is to insert a node at the end of the linked list. And the third is to insert a node after a given node. And to solve these function, let me start with insert a node at the front of the linked list. So we are gonna move forward one by one, and let's see. See here, this function insert at the front. So अब मुझे क्या करना है? I need to insert a node at the start of the linked list. Currently, my linked list contains, now currently you can see here, my linked list contains only these 3 elements, 1, 2, and 3. So currently my linked list is like this. 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to null, right? Now, let's say I want to add, let's say 10. I want to add 10 in front of this linked list. This is my whole linked list. I want to add 10 here in front of 1, like this, correct? So this is what I want my output should be in this case. So let's start doing it. Okay. Now to insert any node, any element, we need to process through these 3 steps. These 3 steps are so important. You can just write it. See, this is the algorithm for it. There's a step by step how you can insert any element at the front. So first is you need to prepare a new node. Second is put it in the front of the current head, which means here I'm putting the 10 value in front of this 1. Okay. And third is move the head of the list to point to the new node. Okay. So first of all, what this insert at front function is going to receive here in the parameter, in the argument section, what should I pass here in this insert at the front function? I am going to pass the node. Which node? The head node. See here, I am inserting at the front, so I will pass the head node. So what I'm doing is node So here in this function, I pass the head node and this int value. Now, what is this value? This value is 10. This is what I need to do now. I want to add 10 in front of 1. So I'm passing this value, int value, and I'm passing the head of the linked list. So first of all, first step is to prepare a new node. For preparing, we can just write node. Let's say the new node name is, let's just write the new node. So this is the name of our new node. Okay. And for creating, I'm just using this. So this is the whole, this is the line. And this line represents that I am preparing a node which has a value of 10 and it's pointing to null. Okay, this line represents this thing. 10 is pointing to null. The second step is put it in the front of the current head. Now what I have to do is I need to put this 10 in front of 1. So it's very simple. Just write new node. Okay. Now what I'm doing here is currently my 10 is pointing to null, right? My 10 is pointing to null. So what I'm doing is I'm making sure that my 10 is now pointing to 1. Okay. So this second line, new node next is equals to head. This represents that now I'm pointing 10 to 1. And this third line, move head of the list to point to the new node. But still, you see, my head is still at the 1 place. My head is still pointing to 1. So in order to make sure, in order to make this 10, the new head of this linked list, I'm gonna write this. Now my head will become this new node. So this third line represents that now my head from the 1 is moved towards a 10. So if I want to print this list, this thing, then the output should be like this. 10 is pointing to 1, 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to null. So instead of 10 here, it should be value. Since we are going to pass here, let's call this function. The function name is insert at and here I would pass head and the value. Let's say 10. My output should be like this, 10, 1, 2. Okay. This is value. So this is how my list is showing. 10 is pointing to 1 and in this way. So you can understand these are the 3 basic steps to insert any element at the front of the linked list. First, you need to prepare a new node. Then you are putting it in the front of the current head. Whatever the current head is at that time, you are just making sure that your new node is pointing to the current head. And in the end, you are just making sure that now the head is this new node, okay, which is this third step. So in these 3 steps, you can just simply perform the insertion at the front. And now we will see the insertion at the end. Insertion at the end is also similar to the way we did in this case. And insert at the end is also going to take the same parameters. Okay, so first of all, let's take the example. Let me just. So now I've just removed this part. And now currently my linked list is like this: 1, 2, 3, and none. Okay. Now this time, let's say I want to add 100 value at the end of the linked list, which means now I want my linked list to look like this. 1 is pointing to 2, 2 is pointing to 3, and 3 is pointing to 100, and 100 is pointing to null. This is what I want to do in this function. So insert at the end is going to take the same parameters. First of all, head value and this int value. And to perform this insert at the end, to perform this function, to insert any node at the end of the linked list, we are gonna use these 4 steps. First step is same. We need to prepare a new node, and this new node is 100. So the first step is we need to prepare this node. 100 is pointing to null. This node. Okay. In the second step, we are checking if the linked list is empty or not. See, what if my linked list doesn't contain any element? In that case, whatever the element I'm going to insert in my linked list is going to be the first and the last and the only element present in the linked list. So if my linked list is empty, then the new node, whatever the new node I have inserted, will become the head node. Right. And the third step is if my linked list is not empty, then I'm going to find the last node. And after finding the last node, I will insert a new node after the last node. See, first of all, just answer me this. Currently, my linked list is like this. Now, this is my linked list currently. Okay. Now, tell me what is the last element in this linked list. In this linked list, what is the last element? 3. So in this linked list, the last element is 3. And which element knows where the 3 exist? मतलब कौन सी नोड जानती है कि 3 कहाँ पे exist करता है? Which node has the address of 3? 2 knows, yeah, 2 knows. And which node knows where the 2 exist? 1. Okay, which means the head node. 1 is our head node. So the head node knows where the 2 exist. So now here you can see the downside of this linked list, that in order to find just one element, we need to traverse the whole linked list. But that is not the case in the array. We know array, just by knowing the index value, we can just print the element, whatever element is present at that index. But in linked list, in order to find any element, you need to traverse the whole linked list. So here, to find the last element, I'm going to traverse this whole linked list, and then I will insert it at the end. So let's start it one by one. So first step is prepare a new node. See, this is how I prepare the new node. Let's just copy it. Okay, so this is how I'm preparing a new node. This line represent this thing. If I have taken 100 value, if I have taken the value 100, so this line represent now 100 is pointing to null. Okay, now second step, what if my linked list is empty? If my linked list is empty, so I'm checking if head is equals to null. If head is equal to null, if my linked list is empty, then whatever the new node I'm going to add in this linked list is going to be the first, the last, and the only element. So in this case, our head will become n, and we will just simply return it. We don't need to go for this 3 and 4 steps, since there is only one single element, and that is going to be our. This is new node. Okay, so we don't need to move towards the 3rd and 4th element. We can just simply return it from here. But if our linked list is not empty, we are going to find the last node. And how we can find? We have just already seen by traversing the whole linked list. So let's say, let me just take a temporary node. And this temporary node contains head. Now, see why I'm taking this temporary node, because I don't want my head to move to the whole linked list, right? If I make my head to move towards the whole linked list, then my head is gonna point to the end element. So that is not what I want. So I'm just making sure that my head is in this temporary value, is in this temporary node. Now, the same way we have traversal. Temporary. Instead of temporary, let's take it last element, since we are finding the last element. Last. Last next is not equals to okay. Now see, I've taken this temporary node. This node, last node, is gonna contain the address of the last node. This last node is gonna contain over the address. And what I'm doing here is, in this while loop, I'm running my while loop until or unless the element, any of the element is pointing to null, which means that in this case, 1, 2, 3, and null. First, first here the value is 1. In the second traversal, 2 value will come in the node, and in the third case, now in this third case, my 3 is pointing to null. So at that moment, this last node is gonna contain this third value, 3. So in this way, we can find the last element in the linked list. And now the last step is insert this new node after the last node. So the last node is present in this last node, and we're just simply pointing the last next to this new node. See, earlier this last next is pointing to null, but now my last next is pointing to this 100, which means now my linked list is gonna look like this: 1, 2, 3, 100, and null. Let's try to run this code and see what we are getting. Insert it end. I'm passing head and I'm using the same value 100. So this is my linked list now: 1, 2, 3, and 3 is pointing to 100 and 100 is pointing to null. So in this way, in these 4 steps, just write these steps somewhere, because these are the same step for any language, in whichever language you are doing, whether it's Java or Python. These 3 steps is gonna apply. First, you need to prepare a node. Second, you are gonna check if the linked list is empty, because if the linked list is empty, then our new node will become the head node. And if the linked list is not empty, we are gonna find the last node. And the moment we find the last node, we will point the last to this new node. Okay, is that clear? Okay. Let's move towards the last type of insertion in linked list, which is to insert after. Let me just collab these functions. Okay, so let's see this part. To insert any value, any node or any element after the last node. See, to insert any value or any node after a given specific node, let's understand there are again 3 steps. First, we will check whether the previous node is null or not. See, if the previous node is null, then we cannot add any value in it. So we are just making sure that the previous node is not null. And the second step is to prepare the new node, the node which we are going to add in the linked list. And in the end, insert the new node after previous. So let's start here from this side. So first of all, we are checking if the previous is not null. If before starting, let's see what this function is going to receive. This function is going to receive the same thing. This function will receive the value which after which I want to add any node. So let's take this previous. So this previous contains whatever the node I want to add after this node. And here is the value. This value is same like we have used in these functions. So this value is also the same one. Currently, let's take the same example, 1, 2, 3, and null. My linked list is like this, 1, 2, 3, and null. Let's say I want to add any number, let's say 4. Let's say I want to add 4 after this 2. So if I want to add, my linked list is gonna look like this. 1 is pointing to 2, and 2 is pointing to 4, and 4 is pointing to 3, and 3 is pointing to null. So this is what I want to happen in my linked list. I want to add 4 after 2. Okay, and this is the node. So first of all, I'm checking here if my previous node is null or not. Because if my previous node is null, I cannot add any value. So I'm checking if previous equals to null. And see if my previous node is null, then I cannot add any node after it. So I'm just writing that previous can not be null. And I will just return from here. But if my linked list, see here, I have taken this example. It is not a empty node. It is not an empty linked list. So here I need to prepare a node. So we are going to prepare in the same way that I have prepared earlier, like this. Node restrict. Let's take the new node B. New node and I prepared a new node, and this node is this 4. Here we have taken the example of 4. So this line represents. Okay, so this line represents this thing. 4 is pointing to null. The second case is, the last case is insert a new node after the previous. So for this, let's use this one. Okay, let's assume this is my linked list currently. A is pointing to B, B is pointing to null. And here is this element C. This is a node that I want to add in between A and B. Okay. So let's see. For that, what I should do? I should see currently the A is pointing to B. So I need to make sure that A is now pointing to C. And the moment A is pointing to C, this link is gonna break automatically, and C is gonna pointing to B. So this is what I want to do. I want this A to point to C, and the C is gonna point to B, and so in this way. So let me just ask you, see here, earlier, the linked list is like this. A is pointing to B. Now I have said, just pay attention to my words. See, the moment I make my A node to point to C, this link is gonna break automatically. And in this whole memory, see, linked list is not a contiguous segments of blocks. It's not like arrays. These nodes can be anywhere in the memory. So only this A knows where this B exists. Nobody knows in the memory where this B exists instead of A. I mean, only सिर्फ A को पता है कि भाई B कहाँ पर है. तो if I just so if my first step is like I'm making sure my A is pointing to C, then this node will be lost forever. So instead of doing that, instead of making this first step from A to pointing to C, I should do this thing. Currently my A is pointed to, this is the thing. And I need to make sure that first thing is, let's make this C to point to B. With the help of this A, I can make this link easily. And the third and the second step after this first step is, I will make sure that A is pointing to C. And the moment I do this, this is going to automatically break it. So my step, instead of this, my step would be, first, I will make C to point towards B, and then I will make A node to point to C. So this is a reverse type of order. So let's say my new node, what I want to do is, my new node is gonna point to what? The previous next. Here in this case, we have A. What is, so this is the previous here. In this example, this is the previous, and the previous next is B. Okay, so here, if I consider this new node as C, so I'm making sure that this C node is pointing to B. And the last step is the previous next is going to point to new node. So these are the two steps. First, I have make sure that C is pointing to B, and then my second step is that A is pointing to C. So this is this one step. Let's try to run this. This time it's insert after node, and let's take any node. For example, I want to, in my case, I want to add 4 after 2. So 4 is stored in my second node, and the value is 4. So we are getting the output, this thing, that now 2 is pointing to 4. So in just in this 3 simple step, first of all, I'm checking whether the previous node is null or not. And if it is not null, I'm preparing a new node. And then third step is insert the new node after previous. And we have just taken the reverse order. So first I will making sure that my 4 is pointing to 3. In my example, in this example, I first make sure that the 4 is pointing to 3, and then I have done this 2 is pointing to 4. Okay, so these are the 3 steps, and these are all the insertion methods, operations that you can perform in linked list. In the same way, deletion is also performed. So deletion, yeah, so in the same way the deletion is also performed. So I will share the steps also for the deletion one in the GitHub repository that we have sent yesterday. Okay, so that's all from the problem section side. And if you have any doubts related to insertion or the traversal of this linked list, you can ask in the chat box. And for the deletion, I will share these steps in the GitHub repository, so you can check it from there. And that's it. Yeah.